Hey guys, welcome to Algebra class online. We're going to talk today about Chapter 7, Multiplying Monomials. But before we get to talking about multiplying monomials, I want you guys to take a second, pause the video, and do these review problems we got here. Alright, and when you get back, we'll talk about what it means to multiply a monomial. Alright, so go ahead and pause now. And when you're done, come back. Alright, welcome back. Hope you guys did well on those. If you have any questions about them, we can talk about them in class tomorrow, so just don't worry about them and feel free to bring them up, okay? We're going to talk about a monomial. So what is a monomial? Well, it can be a number, a variable, or the product of a variable or a number, or multiple variables and numbers, okay? But the main thing to remember is that a monomial has one term, okay? And some of you may be thinking, well, what in the world's a term? A term is anything that we have in our equation that is separated by a plus or a minus sign. Okay, so let's look at our examples below and see if they are monomials. Alright, so our first one here, we can immediately see that there's a negative sign here in between what looks like two different terms, right? So we already know that this one is not going to be a monomial because it's separated by a plus, or separated by a negative sign, right? How about for our next one, if we have 3/4, we have a fraction there, okay? Well, that one is going to be a monomial because it has a constant in the denominator. Alright? Since we have a constant in the denominator, 4, we can say that, yes, this is a monomial. Okay? For our next one, we have, looks like the product of a number, 8, variable, f to the second, and another variable, g. So we can go ahead and say that, yes, this is a monomial because it's the product of a number and variables. And for our last example, we have another fraction, but this time, if you look in the bottom, the denominator, we have a variable there. And since it's not a constant and it's a variable, we can go ahead and say that no, this is not a monomial. Okay? Now that we know what a monomial is, we're going to take a closer look at one of our key concepts when we have the product of powers. So when we say the product of powers, if we're multiplying them together, then we're going to add their exponents as long as they have the same base. Okay, that's an important thing to remember. So if we have this exponent a to the m times a to the p, then look what they did there. They just added the exponents together, m plus p. So let's take a look down at our example problem and see if we can simplify those. Alright, so we've got the variable r, another r there, and we have negative 12 in front of the r, and we have a 1 is going to be in front of this first variable. So we're going to multiply the r's together, and we're going to multiply the negative 12 and the 1 that we know is there, but we just can't see it. So 1 times negative 12 is going to give us negative 12. And then r to the 4th times r to the 7th, we're going to add the exponents together, and we will end up getting negative 12 r to the 11th, because 4 plus 7 is 11. Okay, so let's take a look at our next example. We've got the coefficients here are going to be 6 and a 5 will multiply together. We're going to multiply our c's together, and we're going to multiply our d's together. Okay, so for our coefficients, we have 6 times 5, for our first variable, we have c to the first, right, times c to the fifth. And for our d variable, we have d to the fifth times d to the second. Okay, so these are all products here, and we're going to add the exponents together. So for our first, we have 6 times 5 is going to give us 30. C to the first times C to the fifth. We're going to add the exponents. 5 plus 1 gives us C to the sixth. D to the fifth times D to the second is going to be 5 plus 2 will give us D to the seventh. Okay, and that will be the most simplified we can make this equation. Okay, so let's take a look at the top of the next. Let you guys work on number 3 and number 4 on your own, and we will talk about those in class tomorrow. Okay, so go ahead and pause the video and get started on those, and when we come back we'll talk about the power of a power concept. Okay, welcome back. Let's talk about what it means to have a power of a power. Okay, so now instead of multiplying two variables or integers together, we have the base a raised to the power m. All of that is raised to the power of p. So that's what a power of a power is. So whenever we have that, for instance, we're going to multiply the exponents and end up with a to the m times p. Okay, so let's look at our example number 1, and we're going to simplify that. So we've got the number 4 squared. Now all of that is raised to the second power. So we're going to have that is going to be multiplied by 2. And then all of that is raised to the third power. So we're going to multiply that by 3. Then we're just going to simply multiply each of those out. And we'll get 2 times 2 is 4. 4 times 3 is 12. And that will not be our final answer because we can multiply all of that out, and I wouldn't ask you guys to do that by hand, so you guys can use your calculator. And if you use the button where it's a caret sign, and the caret sign just looks like an upside down V like that. So if you hit 4 and then the caret sign and then the number 12, that is the same as saying 4 to the 12th power, and that will give you an answer of 16,777,216, and then that will be your final answer. But we want to make sure that we're writing both this and our final answer. Okay, so you guys go ahead and see what you get for number 2. Alright, and try that calculator function when you get your 2 to the certain power. Alright, and when you get back, we'll talk about the power of a product. Okay, let's take a look at when we have the power of a product. Okay, so what we're saying by that is, if you look at our example here, we have a times b, which is a product, and that is raised to the power of m. Okay, so what happens here is we're just putting the m on the a, and we're putting the m on the b as well, and we end up with a to the m times b to the m. Okay, pretty simple, right? So let's take a look at our first example. It looks a little more complicated than a times b to the m, right? But what we have here is just a product. We have 8 times g to the third times h to the fourth. All of that is raised to the second power. So what are we going to do? We're going to put the 2 with the 8, we're going to put the 2 with the g, we're going to put the 2 with the h to the fourth. Okay? So I'm just going to go ahead and do this first step, but we're going to keep it all in parentheses. So we have 8 to the second, g to the third raised to the second, so that's a power to a power, right? So we're going to multiply those, so we have g to the 6th, then we have h to the 4th raised to the second power is going to be h to the 8th, because we multiply, it's raised to the power. Alright, now we got to remember we have all of that, but it's still raised to the second power again. Okay, so we still have 1, 2 hanging out right here. But before we get onto that, I'm going to do the same thing with our 4 in this part of the problem. So we've got 2 to the 4th, g to the 4th, and h to the 5th times 4 is going to be 20. So we got h to the 20th. Alright, so for the next step, we're going to do the same thing with that 2 that we still have hanging out. So we're going to take this 2, we're going to put it on the 8 squared, the g to the 6th, and the h to the 8th. Okay, so we're going to have 8 squared to the second power is going to give us 2 times 2 is 4, 8 to the 4th. G to the 6th raised to the second power is going to give us g to the 12th. H to the 8th raised to the second power is going to give us h to the 16th. Alright, we have all of that still to multiply by 2 to the 4th times g to the 4th times h to the 20th. Okay, so now we're going to multiply our constants, our g variable and our h variable to get our final answer. So 8 to the 4th, I've already done that on my calculator, and that is the same as 4,096. So 8 to the 4th is 4,096, and 2 to the 4th is the same as 16. Okay, so we're just going to multiply those together, and that will give us our final answer for the coefficients of 65,536. Okay, then we have g to the 12th times g to the 4th. So there we have, we're multiplying those together, right? So we're going to add the exponents. So we get g to the 12 plus 4 is 16th. We're going to do the same with h. H to the 16th times h to the 20th will give us h to the 36th. And that there is going to be our final answer. Alright? So I want you to go ahead and give number 2 a shot on your own, and we can talk about that one in class tomorrow. Okay, let's see how all this power information is important and can be used today. If somebody were to ask us to find the volume of a cube with the side length 5xyz, well, we can use the rules that we just learned to find the answer for that. So the volume of a cube, which we can talk about in class if you have a question, what that means is going to be the side length cubed. Alright, so all we need here is, what's the side length, and we can solve this, right? Well, the side length is 5xyz. So now we just do substitution, and we can find what the volume of the cube is. So I'm going to substitute that in for s to find the volume. So we're just going to raise it to the third power. And we can use our power of a product rule. We're going to put the 3 on each of these in here, and we'll get our final answer. Okay, so our volume is going to be 5 raised to the third times x raised to the third times y raised to the third times z raised to the third. Then 5 to the third is, we can use our calculator for that if we need to, 125, x to the third, y to the third, and z to the third. And that there is going to be our final answer. What if they ask us to find the surface area of a cube, and they want us to express it as a monomial? Now, we gotta notice there they're asking us to express it as a monomial, so they want it in one term, because you can do this in different ways. So we're using this cube over here for this problem, and we can see that the side length is going to be 2pq. Alright, so we can substitute in for the formula for surface area, which is, surface area is 6 times the side length squared. Alright, that's a 2. So, now that's the surface area for a cube, we have to remember. Now there's multiple ways we can find the surface area of a cube, and if you guys figure out, or we can talk more about how I got that formula, or if one of you guys can explain how we got that formula, then I'll see if we can give you some extra credit points in class on Friday. But now all we're going to do here is substitute our side length in for S. So we have the surface area equals 6 times 2pq squared. Okay, so we're going to use the power of a product rule and put our 2 on each of those. And we will get 6 times 2 squared times p squared times q squared, which will give us 6 times, now what is 2 squared? 4p squared q squared. And our final answer, we're going to multiply the 6 and the 4 to give us 24p squared q squared. And that is our final answer for that problem. Thanks for watching, and remember, if you can come in and tell me about that surface area, then we'll see if we can get some extra credit points on Friday. See you guys tomorrow.